Okay, dear students, another question from moment of inertia. Very good. So two small spheres, each of mass 10 kg, are 8 meter apart and connected by a rod of negligible mass. So you have to consider this. Because in these kind of questions, like when you're talking about the moment of inertia, the masses become very important. So if the rod was having the mass, the moment of inertia for the rod has to be either like remembered by you, or it should be given by in your formula sheet or something, like it will be given in your question something. So be very careful about what kind of masses are given in your moment of inertia. So there are only two masses we worry about. This is 10 kg and this is also 10 kg here. Okay, fine, no problem. This system rotates about an axis halfway along the road and at the right angle to it. So clearly the axis is somewhat like this, and these two, they are rotating like this, easily like this. Very good. What is the moment of inertia of the system? Very good. It's a simple and straightforward question. Listen to me. So in the moment of inertia, usually there are two different type of systems. One is called the discrete system and another is called the continuous system. So continuous system is like the rod in which you have a continuous distribution of mass, like all through the volume. And you can talk about the spheres, you can talk about cubes and cuboid, those 3D diagrams, they are called the continuous system. Discrete system is when you are having this kind of a problem here, and the mass is supposed to be concentrated at the center here, like this here at the center. You can just assume that the mass 10 kg is concentrated at the center of mass. So such a kind of system is called discrete system, and you do not usually use the calculus for this. Like you can use the simple algebra here. So first of all, the moment of inertia of this will be mr square. You have to remember this formula. So I1 is given as mr square, and I2 will be separately found, like you can say M2R2, M1R1, like that. Although M1 and M2 are same here, R1 and R2 is also having the same value, that is 4 meters. But anyways, so this will be the momentum. Let me find it. The moment of inertia. So 10 into the radius is 4, and be careful about the units. 10 kg is SI, meter is SI unit, so no problem. So it will be 4 into 4 is 16, so it will be 160 kg meter square. That is the unit of moment of inertia. You can derive it from this kg meter square, yeah. And 160 will be for the other ball, kg meter square. So in such a kind of a case, when you have the same axis and both of the masses are attached to the same system, the total moment of inertia is just the algebraic sum, because moment of inertia is a scalar quantity. You do not worry about the vector additions and all. So you just need to add them. So you add it, it becomes 320. So your answer for this question will be 320 kg meter square. This is how we do this question. This is a very important question, I would say. Why? Because number one, it is simple, but it is highly basic. It is the foundational question which can be asked in the topic of moment of inertia. That is why this question is very important. Okay, dear students, thanks for watching this. This is Professor Varun. All the best. Bye.